Hey guys, this is going to be our video on the test 11 review over circles. Alright, so number one, first of all, we are asking to find the measure of the arc of DE, of D, let me get that right, CDE. So in other words, we're going from right here, C, through D, all the way to E. So we're talking about all this right here. You know, I wish I should have done that with a highlighter, but anyway, we're just saying all this right here, going from C all the way to E. Okay, right there on the outside. That's what we're looking for. Well, how are we going to do that? First of all, we are not given any information about the radius or the diameter or anything like that. We're not given anything like that. What we have to do is use the fact that angle measure. This will make more sense in a second. That angle measure is equal to arc measure. Arc measure. And this is what we're being asked to find here. We want this arc measure. All this over here. Okay, well, how are we going to do that? First of all we need to do is find, okay, what is this angle? This 27 and this one over here. That O. Well, how are we going to find that? Well, first of all, we're given all the other ones. We're given 27, we're given 103, we're given 50, we're given 35. 27 and 103, that's 130 plus 50 is 180. 180 plus 35 is 215. Well, all the way around a circle is 360 degrees. So all we have to do is find the difference between the 360 and the 215, which we already know is in here. So I'm just going to say that this is going to be 360 minus 215. And this is 145. This is not your answer. This is just telling me that, okay, this is going to be 145 in here. Okay, well, how are we going to use that information? Remember that fact that I just told you over here. Angle measure equals arc measure. So if I'm looking for this arc measure, that's all I'm being asked to find the measure of arc CDE. All I have to do is be able to add these two angles together. So since I have that, I'm going to say 27 plus 145. And 27, sorry, you can't see that. 27 plus 145 is going to be 172. Okay, so that is going to be my answer here, 172. It's a little blurry right there. 172. Okay, so let's go to number two. Number two, find the circumference. Well, remember, you have two formulas for circumference. You have either C equals 2 pi r, or you have C equals pi times diameter, which is the same thing because, you know, your diameter is just 2 times the radius. So same deal right here. Well, what I'm given here is my diameter. I'm given that D is equal to 5.7 centimeters. So since that's what I have here, since I have diameter, I'm going to go with the second formula, the pi times diameter. And here they're being asked to give our answer in terms of pi. So that means that we want pi in our answer. So I'm just going to say that, all right, my circumference is going to be pi times diameter. So I'm just saying pi times 5.7, and this is centimeters. And since I want pi in here, I'm literally just going to put this together. The protocol when you're multiplying a number and a variable, even though that's a constant, that's considered a variable. The number goes first. So 5.7 times pi centimeters. Okay. Then this week I had a student ask, well, can't you say pi 5.7? Well, technically you can, but just the way, you know, math tries to be very orderly, anything that's written after a variable is considered an exponent, or you would only do it if it was an exponent. So that's why we wouldn't say pi 5.7. This has to be 5.7 times pi, and then of course our units here are centimeters. Okay, let's look at number three. The circumference is of a circle is 64 pi centimeters. We want to find the diameter, the radius, and the length of an arc. Okay, given that we have this angle of 190 degrees. Okay, so first of all, you're given circumference. They gave you that right here. Your circumference is 64 pi centimeters. Okay, so I'm going to say that C is going to be 64 pi. Okay, remember from the formulas we just looked at up here, circumference is 2 pi r, or it's pi times diameter. I'm going to go ahead and go with that pi d here. So I'm going to say pi times diameter is equal to 64 pi. Now, I could have also said 2 pi r equals that. It really doesn't matter. What we're going to do here is try to solve for diameter. If I had said 2 pi r equals this, the same thing, I would have just done that to try to find then the radius. Between diameter and radius, if you find diameter, which we're about to have, then we would just half that to get my radius. If we did the 2 pi r equals 64 pi, then we would do that to solve for r, and then we would just double the radius to get the diameter. It really doesn't matter. It's going to be the same thing. Anyway, to me, this is a little more simplistic. If we divide that pi away on both sides, we're just going to wind up with, I don't have room, so I'm going to skip that step. I'm just going to say that diameter is going to be 64, and this is centimeters. Okay, so now that I have diameter, I'm just going to get half of that to get my radius. Well, half of 64 is 32. So bam, I have my diameter and I have my radius. So now I just need the length of an arc. So when you're talking about the length of an arc, you're talking about basically just a piece of your circumference. Well, they gave us our circumference over here. So how are we going to find this? We're going to use a formula. We're going to say the angle, which I'm going to say is m. I could have also said this was theta. Either you call this m or you call it theta, which we are going to call it theta in a couple of problems. It really doesn't matter. Basically, that's just your angle. I'm going to divide this by 360. Remember, it's 360 all the way around. So in other words, we're saying whatever angle we have here, we're going to divide that by 360 because we just want just a portion of the circle. We don't want the whole circle. Talking about the circumference. And then we're going to multiply this by the circumference. And we can do this because, first of all, they already gave us our circumference. That's what the 64 pi centimeters is. So I'm going to do this. I'm going to say equals. So remember, we said that our angle measure is 190. So I'm just going to say 190 over 360. And then times our circumference, which they already gave us. That's 64 pi. And if we did that, 64 pi. We are not asked to give our answer to the nearest tenths or hundredths or anything like that. So we're just going to multiply this together. And if I do that, I'm going to wind up with, and basically I'm just going off of to match those answers that they give us in the back. And this is just going to be 33.8. Definitely do this with a calculator. 33.8 pi. And this is going to be in centimeters. Okay, now personally I don't quite like the way they do that because first of all, they didn't tell us anything about like write it in decimal or anything like that, and they did not tell us to write it in terms of pi, which this is, with the decimal, which just looks kind of funny. But either way, I'm just doing this so we can match those answers that are in the back. Just be prepared to go either way. They could, I've always said, write it in terms of pi. Or they could have said to write it, to the 10th or whatever it is. Okay, so just be prepared to do either one. Okay, so number 4. Find the length of the arc of ypx. So in other words, we're talking about ypx. We're talking about all of this out here, y, p, and then all the way to x. We're just talking about all that on the outside. Okay, so we can use this formula that we just had here on number 3. The angle divided by 360 times our circumference. We could do that. And here, you were given in here our radius. We are going to have to find our angle. Remember, this is 360 all the way around. And we are given that we have in here, we have this sector that has an angle of 90 degrees. So if I say 360, and I say 360... minus 90. This is going to give us 270 degrees, which for this formula I'll say is my m. Okay, so So I have that, and I have my radius. I'm saying r equals 10, which I'm going to need because, remember, for circumference. So anyway, let's lay this all out. So I'm going to say m over 360 times my circumference, which is going to be 2 pi r. I'll put that together because that's all going to be our circumference over here. Here, let me do that just to kind of separate that. Okay, so my angle right here is going to be 270. So I'm saying 270 divided by 360. And I'm multiplying this by 2 times pi times the 10 meters that I was given. Okay. And this is circumference, so my answer is just going to be units to the first power at the end. So my answer will be in meters. So if you do this in a calculator, first of all, and this set to write our answer in terms of pi. So we can just keep the pi. In other words, pi is going to be in our answer. So I'm going to put that down there. So on your calculator, all you're going to say is 270 over 360 times 2 times 10. And if you do all that, you are just going to get 15, which is nice and neat. I personally like to write this in terms of pi. It helps to not have to refer to a calculator and have to do this to a certain number of decimal points or whatever it is. Okay, so that's just 15 pi. Okay, let's look at number 5. Find the degree measure of angle 2 pi over 10 radians. So here we want degrees. So we're going to have to go from degrees. We want degrees, so I need to go from radians to degrees. So I'm using the let me get it out. I'm using the conversion from radians to degrees. So since I want degrees, I have to multiply by, I'm going to have to multiply that angle, 7 pi over 10, by, first of all, you need to introduce degrees in here. So you're going to have a fraction that you're multiplying by 180 degrees is going to be on top, and then I'm dividing away pi. How can you tell the difference here? First of all, you need degrees, so degrees has to be on top. And get it, if you have pi, just think about it, if you have pi, you have radians. So get it, I'm dividing away the radians, so I'm dividing by the pi. So anyway, so if I multiply now, I can divide those pi's away. So I'm just going to have 7 times 180 over 10. Okay, well 10 will go into 180. So that'll cancel a 0 there. So basically now I'm just saying 7 times 18, and 7 times 18 is just going to give us 126 degrees. Okay. So yeah, that's that. Okay. And now we're going to do the same thing on number 6. Okay. But here we want radians. We were in degrees, so here we're going to do the other conversion where we're going from degrees to radians. Okay. So if we want radians, our conversion is that we have to multiply by pi divided by 180. So just like I just did this here, where I had to divide away the radians, here I need to divide away the degrees, which is exactly what's going to happen here. Let me put that 110 over 1, and let's multiply across. So here you can literally see that your degrees are going to cancel each other. And this is just going to be 110 pi over 180. Here you can cancel 0 top and bottom. So we can just say that this is going to be 11 pi over 18. And bam, we're done. That is our angle in radians. Okay? All right, let's look at number 7. Okay, we're asked to find the length of S. We're asked to find arc length. Now, this is going to be another way we're going to do this. We're going to have a nice simple formula. So if we're just looking for S here, we're just going to use the formula S for arc length is equal to our radius times our angle. Okay, well, we're given our radius, which is 3, and we're given our angle, which is 2 pi over 3. So a little while ago, we used M for our angle. Here we're using the Greek letter theta. Either one you do is fine. Now, anyway, the only way to be able to do this, your angle absolutely has to be in radians. One reason that you'd want to use radians instead of degrees is because radians is an actual number. That you get it, then you're just multiplying a number times a number. If you were saying a radius of 3 meters and we're multiplying that times 2 pi over 3, which is actually 120 degrees, that's just kind of weird to say a number times a degree like that. So anyway, we would not do that. We can only do this if this is radians. So anyway, I'm just going to say 3 times my angle of 2 pi over 3. Okay, so if I multiply this now, I could put this over 1 if I wanted. But anyway, those 3's are going to cancel. This is just going to be 2 pi. And this is going to be meters. Okay. Now, they did say to the nearest tenth, so I'm not done right there. If they wanted the answer in terms of pi, I'm done right there. But you're going to actually have to put that in the calculator. Say 2 times pi. And if you did that, your degree is going to end up being 6.28 and change. So I'm just going to say 6.3 meters. Okay. All right. Now, number 8. So let's find the area of the circle. So the area of the circle, we have a nice little formula. We're saying the area is equal to pi times radius squared. Well, we're given here a radius of 2.2. So I'm just saying pi. And don't forget, pi is a number. It's 3.14159, blah, 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 blah. So I'm just going to multiply this by 2.2 squared. 2.2 squared is going to be 4.84. So anyway, if I multiply that by pi, this is just going to be 4.84 pi. So I'm done right here. They did say that they wanted that in terms of pi. So I am done right here. My area is just going to be 4.84 pi. Okay. All right. Now let's look at number 9. So find the area of the figure to the nearest tenth. So that's 1 decimal place. Okay, so first of all, we just want the area of this little part. So remember, if this is just one part of the whole thing, this is a sector. So we're looking for sector area. So you had an assignment before on this for sector area. So nice little formula. So remember how up here we had that formula, actually on the previous page, where we had the angle divided by 360 times our circumference for just the arc length, for just a piece of that circumference, not the whole thing. We basically have a formula that resembles that. Okay, that's the wrong page. Okay, so we're going to use a formula that resembles this, what we did before, which is to say that angle divided by 360. But since we just want just a portion of that area, we're just going to multiply this by our area. Okay, well, what is the area of a circle? Remember, we had that from the previous problem. That's pi r squared. So basically, I'm just saying our angle over 360 times pi times radius squared. Okay, and fortunately, we're given our angle, so there's our m, and here's our radius is 7. So if I punch all this in here, I'm just talking about 165 over 360, and then we're just going to multiply this by pi times 7 squared. Of course, 7 squared is 49, so I'm just saying 165 over 360 times pi times 49. And when we're doing this, we are going to end up with, I wrote this down, I already forgot that. So this is going to be just like what they have in the back. This is going to be, put this in a calculator, you're going to wind up with 70.554935 and change. Because they just wanted it to 1 decimal place, I'm going to round this to, I'm going to say that this is going to be approximately. Remember, the 2 squiggles like that means approximately. This is just going to be 70.6 and this is going to be meters squared. Remember, area is always units squared. Okay, so I just said 165 over the 360 times pi times 7 squared, which is just going to give us 70.6 meters squared. Okay, so now we're looking at number 10. Find the area of a sector with a central angle of 170 degrees and a diameter of 9.1 centimeters. Round our answer to the nearest tenth. So that's 1 decimal place. So we wanted the area of a sector. So we just did that in the previous problem where we had our area of a, let's just write it like this, the area of a sector. Okay, remember you're talking about angle over 360 times pi r squared. Pi r squared is the area of that circle. So in other words, I don't want all the area of the circle. I just want just a piece of it. That's what the angle divided by the 360 is given, just this the portion of that. Okay, so anyway, I'm already given here that I have an angle of 170 degrees. Okay, they gave us that right there. And we have a diameter of 9.1. So that means that D is 9.1. Well, for this formula, I'm going to need radians. So I'm just going to say then that my radius is just 9.1 divided by 2. And 9.1, you can say that 9.1 divided by 2 is just 4.55. And this will be in centimeters. Okay, anyway, so when I do this formula, so I'm going to have 170 over 360 times pi times 4.55 squared. And when I do all this, okay, when I do all this, I just want 1 decimal place. So when I do that, I'm going to come out with 30 point something. 30 and change, so this is going to be 30 point, this will round to 30.77, and this is going to be centimeters squared. Okay, I'll just do the squiggle. So approximately 30.7 centimeters squared. Okay, 30.7 centimeters squared. Okay, now number 11, we want the area of the sector, which is this that we just found up here. But here, they're actually giving this to us. They're telling us that the area of the sector is 20.25 pi square feet. And they want the exact area of just the shaded part. Okay, so first of all, they said the area of a sector. So in other words, we're not talking about all this out here. Sorry, I got blurred for a second. They don't want all this out here. We just want this little portion in here. This triangle and this shaded part right there. Okay, essentially, we're just talking about this little part right here. Okay, we just want that. We're talking about that triangle and that area that's shaded part. That's what they're giving us. That is what is 20.25 pi. So let's just write this off. So I'm going to say that the area of the sector is the whole thing, but I want to subtract away the area of that triangle. If you all recall from last semester, whenever we did it, the area of a triangle is just the base times the height divided by 2. So here, this is your radius here. This is 9. So this is 9 here. This is also my radius. So that means that this is also 9. Okay. So the area of that sector, remember, that's what they gave us. That's 20.25 pi. And then I'm subtracting away the area of this triangle, which, remember, base times height. I'm saying base times height over 2, which means that this is going to be minus 9 times 9 over 2. And, of course, this was 20.25 pi. Okay. Anyway, 9 times 9 is 81. 81 divided by 2. Just carrying this down. 20.25 pi minus 81 over 2. Half of 81 is just going to be 40.5. And I want 20.25 pi. Okay. Now, here, how did they want the answer? It just says find the exact area. Find the exact area. So in other words, whatever we get is what we get, which is this. And remember, our area is units squared, which is going to be square feet. So I'm just going to say all this together. That's why I'm putting in a parentheses, and then I'm saying square feet. Okay, so that's it. So this is your answer right there. It doesn't look pretty, but that is our answer. 20.25 pi minus 40.5 square feet. I did not mean to go through the 2 right there. I'm sure y'all will understand. Okay. Okay, so that's that. Okay. So now for 12, 13, 14, and 15, we're going to be talking about circles. So what you need to know about a circle is when you have a circle, let me just kind of do a little mini lesson right here, just as a refresher. So when you have a circle, that's not the most perfect circle, but let's assume it was, right? Circles have a center and they have a radius. So I'm going to say that that's C and this is R. Okay, whatever that C is, that's going to have the coordinates h comma k. Okay, so in other words, h is going to be the x coordinate for your circle, and k is going to be the y coordinate for that circle. And you need this because in an equation of a circle in standard form, write that equation of a circle standard form. Anyway, so this part's important. This is going to be x minus h quantity squared plus y minus k quantity squared equal to radius squared. So all we need is the center, and we need the radius, and then bam, we got the equation. We just got to plug it in. In geometry, all you need to do is be able to identify the center and the radius from a circle, either looking at it or being given that. If you're given it, you need to be able to take the center and determine what h and k is, so you can just plug that in. So you can get this, so you can get your radius and square that. And anyway, that's it. Anyway, so with that being said, let's look at what we're given on number 12. We want the standard equation of a circle, which is what we have over here: x minus x quantity squared plus y minus k quantity squared equal to r squared. So I'm given this right here. Now, when you're looking at this here, this is not going by ones, this is going by twos. Okay, so first of all, I need to find the center. So my center is right here. Here's my circle, and then right there in the middle is going to be my center. I just need to find the coordinates. So remember, this is going by 2, right? So that's 2, and then this is going to be between 2 and 4. So I'm going to say that here my x is going to be 3. So for my center, I'm going to say that this is going to be the point 3 comma, and then I'm going to go down. Just one of these, but remember this going by 2, so that's going to go down to -2. So bam, there I got my point. Okay, so that means that this is my h and this is my k. Okay, now I just need my radius. So from this point right here, I just need to see, well, how can I get to my I guess the edge of the, to the outside of the circle. So this, for reference, this is nice right here, just being able to say, okay, how do I get to the y-axis right here? Well, remember, this is going by 2, so remember, this is at 3, so I would just need to go 3 to get over here. That's, 2 right there, and then 1 right there. So this is just going to have a radius of 3. So I'm going to say here that I have a radius of 3. I had my my center 3, -2, and I have my radius 3. So now I have everything I need to get my equation. So I'm just going to follow what I have right here. I know I kind of shoved all this in here, but in other words, this means I'm going to have x minus my h, which is 3, quantity squared, plus y minus my k. Well, here my k is -2. So since you're subtracting a negative, this is going to become a plus. So this is going to be +2 squared equals 3 squared. So 3 squared is 9. So anyway, so I'm looking for this equation here. This is giving it to us multiple choice, so we just need to find this. So first of all, I'm looking for x minus 3. So a is out, because that's a plus 3, so that's out right there. B looks promising. And then I also had the y plus 2 squared, and this equals 9. So first of all, I'll tell you right now, that is my answer right there, because that's exactly what I want. X minus 3 quantity squared. And this little mark, it almost looks like a 4, but that's just a 2 there. It like kind of got cut off or something. X minus 3 quantity squared plus y plus 2 quantity squared equals the 3 squared, which was the 9. Okay. It's not C because this equals 18, which I did not want. This had to be a 9. It had the x minus 3 squared. Remember, this is a 2. I just cut it off. That's a 2. It's a 2. That's a 2. Anyway, it's not D because that has to be x minus 3, and this was x plus 3. So it's not that one, and it's not that one for 18, so that's why this is B. Okay, so for number 13, we are finding the equation, which we can do, and they have this here for us that we don't have to have the graph. We just had that on number 12. So here I should be able to identify that, okay, this is H, and this is my K, and there's my R. So I plug this into the formula. I'm talking about X minus H quantity squared plus Y minus K quantity squared equals R squared. So let's plug this in. So I'm talking about X minus my H, which is 10 squared, plus Y minus negative 6, because I'm subtracting by negative 6. This is going to become plus 6 squared, and this is going to equal to 6 squared, and 6 squared is 36. So our answer is going to be X minus 10 quantity squared plus Y plus 6 quantity squared equals 36, and that is my answer. I'm trying to box that up. Okay, so X minus 10, because that was my H, plus quantity squared, plus Y plus 6, because I'm saying minus negative 6, so that's plus 6 squared, equals the 6 squared, which is 36. Okay, number 14, we're almost done. Find the center and radius of the circle of this equation. So from this equation, we should be able to look at it. Remember, H is what you're subtracting from the X. So that's why I know that H is 3. And K is what's being subtracted from the Y. So I know that K is 6. And my radius squared is what this equals. So I know that my radius squared is 4. What we're being asked for here is to identify the center and the radius. So for my center, I'm going to say that my C is equal to, this is just going to be 3, 6, because this is just H, K, so 3, 6, and my radius, R, is the square root of the R squared, so square root of R squared is R, square root of 4 is 2. So there's my radius, and this was my center. Oops. So my center is 3, 6, and my radius is 2. I kind of went in there, but that's that. Okay, and last one. So number 15. So you can bother going through this. Here, I'll read it for you so you don't have to. A manufacturer is designing a two-wheeled cart that can maneuver through tight spaces, blah, 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 blah. On one test model, yada, yada, yada. Okay, we have the equation basically. All that which they just talked about is modeled by this equation. Well, this is a circle right here. Now it says, what graph is this? So first of all, let's identify our center and our radius. So just looking at this here, remember, your H is what's being subtracted from X. Well, here I have plus 1.5. Remember, if this is plus, that means it's negative. So this means that this is, our H is negative 1.5, and our K is what's being subtracted from Y. Well, here this is plus. So again, this is going to be negative, so our K is negative 1. And what is the graph? Okay, so I'm going to go through this and I'll show you why all the ones that are not your answer are not your answer. Oh, and then our radius squared is 9. If our radius squared is 9, square root of both sides, that means that I'm looking for a radius of 3. Okay, now the way this looks, I personally don't like the way this looks. I want a center of negative 1.5, negative 1. Well, this is going by 2, so it's kind of hard to be able to see this. Anyway, let's look at D, because D looks like it should be this. Okay, remember this is going by 2's, right? So this, this is at 0, and I'm going all the way over here to negative 2, and this is more than the negative 1, and it looks between negative 1 and negative 2, so we could say negative 1.5. So we could say that that's the negative 1.5, and then we're going down, let's say like right here would be negative 1. So this pretty much is our center right here. So let's look at our radius. So our radius right here, how much do we need to get from the center to the outside of the circle? So this would be 2, 4. This is halfway between this right here. So let's say this is a radius of 5. Well, I don't want a radius of 5. I want a radius of 3. So I know that this is not D. Okay. Let's look at B. Okay, first of all, this is not even where it's supposed to be. This looks like that this would be maybe like 0.25 or something. And this is all positive anyway. Remember, because these are both negative, I should be in quadrant 3. This is not in quadrant 3. You know, talking about the center. So B is out. Okay, let's look at C. So, first of all, remember here, halfway between 0 and negative 2 is negative 1. So it looks like a negative 1 for my x. Well, I don't want a negative 1 for x. And then this looks like it's going down to almost negative 2. So this looks like this would have been a y value of negative 1.25. Basically, negative 1.5. This one looks like this would be switched. Like this would be negative 1, comma, negative 1.5. So that's a switch, which is not what I wanted. So this is out. Okay. And by the way, this looked like this would have a radius of 3. That'd be like 1 and then 2. So that'd be a radius of 3. But either way, it's not going to be C. So this has to be A, which, of course, this is the answer. So if you look at this here, my x value, I'm looking for a negative 1.5. So halfway between here's negative 1, and this is between negative 1 and the negative 2. So I guess you could say that that's negative 1.5. And this is going down, looks like between the 0 and the negative 2. So I could say that my y value is a negative 1. So that looks like the right center. And then let's look at the radius. This would be going over 2 and then 1 more. So this would have a radius of 3. So anyway, this is your answer. Personally, I don't like this. To me, it's still not really clear like that. The way this is, I don't like the grid with 2 line spaces, between them. But either way, that's that. So that is your review. Please go over this, study this, and if you have any questions, as always, please message me in Canvas, or email me. Yeah, and please watch the videos over and over again. And all right, and feel free to subscribe and doing all that kind of stuff. And I will see y'all later. Make sure you take your test. Best of luck. I will see y'all later. Bye.